Hello everyone, this is Sheikh Hania of Sri Venkateshwar College of Engineering. Today I am here to present the presentation on one of the topics of biology of engineering, that is echolocation. In echolocation, we are going to cover ultrasonography and sonars. So in the further PPT, we are going to cover the following topics, that are what is echolocation, principle of echolocation, ultrasonography, uses of ultrasonography, sonar, use of sonar, and some of the application related to them. So moving forward, firstly we'll see what is an echolocation. So what is it? So it is a psychological process for locating distant or invisible object by means of sound waves reflected back to the emitter by the objects. Echolocation is used for orientation, obstacle avoidance, procurement, and social interactions. Scientific study of echolocation in animals began in the early 20th century with the pioneering work of British naturalist Donald. Echolocating animals include mammals and especially toothed whales and some bat species, and also using similar form species in other groups such as squirrels. A few bird species also echolocate, including two cave-dwelling bird groups, that so-called cave swiftlets, and in the genus Aerodomes, and unrelated old birds. Griffith's research also showed that the bats using echolocation to navigate and hunt, and also helped them lay out foundation for the modern study of biological echolocation. In technology, the use of echolocation can be traced back in the early days of submarine warfare. During the World War I, British Navy developed a primitive form of sonar that is called ASDIC to detect the submarines. Now we'll see the principle of echolocation. Principle of echolocation. So generally, echolocation occurs when animal emits a sound wave that bounces off an object, returning an echo that provides information about the object's distance and size. Echolocating animals emit calls out the environment and listen to the sound echoes of those calls that return from the various objects near them. So now we'll see one of the topic that covers under echolocation, that is ultrasonography. So what is an ultrasonography, how it is work and uses, we are going to see in the forward slides. So ultrasonography is a medical imaging technique that uses high frequency and sound waves to produce images of internal organs and tissues of the body. It is also known as ultrasound imaging or sonography. The ultrasound machine emits high frequency sound waves, usually at the range of 2 to 18 MHz, that travels to the body and bounces back off the internal organs and tissues. The returning echo are captured by ultrasound machine and used to create images of the. So moving forward, we can now see what are the uses of ultrasonography. So uses are limited depth, operator dependency, limited resolution, limitations in overweight patients. So ultrasonography has limited depth and it's not effective at imaging deep structures or those obstacles by the bones. And the quality of the images produced by ultrasonography depends heavily on the skills and experience of the operator. It has limited resolution compared to the other imaging methods, making it less effective at visual small structures and detecting small changes in the tissue. Ultrasonography may also limited useful in overweight patients due to difficulty in obtaining clear images throughout. And some more are vascular imaging, eye and neck imaging, emergency medicine, and limitation in detecting some type of cancer. Ultrasonography is used to image blood vessels such as arteries and veins to diagnose conditions such as blood clots, blockages, and many more. It is also used to image the eye and the neck, diagnose conditions such as cataract and thyroid, and many more. Ultrasonography is also often used in emergency medicine to quick and accurate diagnose. It also helps in detecting certain types of cancer such as pancreatic cancer, and which is due to of characteristic signs of ultrasound. Advantages of ultrasonography. So some of the advantages are non-invasive, no ionizing radiation, real-time imaging, portable, effective, and versatile. So ultrasound does not involve any kind of injection and make it safe and convenient imaging method. It does not use ionizing radiation, making it safer option for patients, especially pregnant women and children. Ultrasonography provides a real-time imaging that can be used to monitor and movement the function of internal organs and tissues in real time. It is a portable machine and can be used in variety of settings, making it valuable tool for emergency and rural medicine. Ultrasonography is cost-effective imaging method that does not require any special preparation or recovery time. Ultrasonography can be used to image wide range of structures, body including the organs of abdomen, pelvis and chest. So next topic that we are going to cover in this echolocation topic are sonar. So what is sonar? Sonar stands for sound navigation and ranging or sonic navigation and ranging. It is a technique that uses sound propagation to navigate, measure distance, communicate with or detect objects on or under the surface of the water such as other vessels. Sonar can refer to one of the two types of technology, that is passive sonar means listening for the sound made by vessels, and active sonar means emitting pulses of sound and listening for echoes. Sonar may be used as a means of uh, acoustic location and measurement of the echo characteristics or target in the water. Acoustic location in the air were used before the introduction of radar. Sonar may also be used for robot navigation and sonar. An upward looking in the air sonar is used for atmospheric investigation. The term sonar is also used for the equipment used in generate and receive the sound and acoustic frequencies used in sonar systems vary. Sound is known as underwater acoustic or hydroacoustics. The first recorded use of technique was in 1940 by Leonardo da Vinci, who used a tube inserted into the water to detect vessels by ear. It it was developed during the World War One to counter the growing threat of submarine warfare with an operational passive sonar system in use by 1918. Modern active sonar systems use an acoustic transducer to generate sound waves which is reflected from the objects. So now the uses of sonar are naval application, fishery, oceanography. So in Navy they use sonars and it is very helpful for the people. That is, sonar are used by naval vessels to detect and locate other ships, submarines and underwater obstacles, allowing them to navigate safely and avoid potential collisions. Fisheries. Sonar are used in fishing industry to locate schools of fishes and determine the depth of the water, allowing fishermen to more efficiently target their catch. Sonars are used in oceanography to study the physical and biological properties of the ocean, in- including the structure of ocean floor, the movement of currents, and the disturbing of marine life. Also, it's helpful in environmental monitoring. Sonar are used to monitor the health of marine ecosystem, track the migration pattern of whales and other submarine mammals, and accessing the impact of human activities on the ocean environment. Sonar technology works by emitting a series of sound pulses and listening for the echoing that bounces back for underwater objects. Acoustic noise. The use of sonar technology can also generate acoustic noise which can disturb marine life and harm marine ecosystems. Complex technology. Sonar technology can be complex, requires specialized skills and equipment to operate and maintain. Sonar reading can also be inaccurate due to frequencies such as diffraction, refraction, and absorption of sound waves, which can also result to be incorrect measurements and false readings. Advantages of sonar technology. Sonar technology is very useful. The frequencies which written back help in a lot of things. So some of these are versatility, cost effective, non-invasive, real-time imaging, high resolution. So versatility is that sonar technology is versatile and can be used in variety of applications such as underwater navigation, mapping and imaging as well as for military and scientific purposes. It can be compared to underwater imaging technology. Sonar is relatively effective and affordable. Unlike the imaging technologies such as diving and remote operating vehicles, sonar does not physically disturb the underwater environment, making it ideal choice for environment monitoring and scientific research. Sonar provides a real-time imaging, allowing operators to quickly and easily access the underwater movement. And high resolution. Modern sonar systems have high resolution capabilities, allowing for detailed imaging of underwater objects and structures. Thank you for watching this presentation. Hope you like this and you have got some information.